Welcome back to the deep dive. Today we're looking at a really specific but important piece of kit.
We are the Thor Broadcast F-16HD-1D-TVI-TXRX kit.
Right. It's a system built to push 16 channels of high-definition video over fiber optics.
A lot of video.
Our mission today is to, get past the product sheet and really dig into the technical advantages of the HD-TVI video standard. We want to understand why these less expensive commercial-grade systems are becoming such a critical solution.
Especially for these huge video infrastructure projects.
Okay, let's unpack this. So at its core, this kit is about moving high-res video, 20 kilometers?
20 kilometers, yeah.
Oh.
Over a single mode fiber.
And to really get how they can pull that off at this price point, we have to look at the engineering, right?
It's all about engineering for simplicity and resilience. For the person installing this, the big takeaway is that these are automated plug-and-play units.
So no complex configuration.
None. They're built with something called SMT surface mount technology.
And what does that mean in practical terms?
It just means it's a more compact, more rugged piece of gear. It's much more resistant to things like vibration and heat.
So that robustness is it's baked right in. That's got to be crucial if these things are sitting in a rack for years.
Exactly. You said it and forget it. You mentioned the fiber connection. That single-mode simplex fiber is what gives you that incredible 20-kilometer range.
Which is a massive operational win.
A huge win, especially for, sprawling sites like a campus or an airport.
What's fascinating here is why HD-TVI is the right tool for this job. What makes it so good for fiber conversion?
Well, technically it supports full 1080p resolution, uses 10-bit digital video encoding, but the real secret sauce is the uncompressed transmission.
Okay, wait. Uncompressed. My first thought is that must require a ton of bandwidth.
That's the beauty of it. It's uncompressed, but it's not packetized like IP data. So if you compare it to, say, IP cameras.
IPC, right.
IPC. For a big installation, the difference is just night and day. Because HD-TVI is uncompressed, you get a totally lossless signal.
No degradation at all.
None. And this is critical, there is zero transmission delay.
Zero. Not even a few milliseconds.
Zero. IPC always has some latency because it's constantly packing and unpacking data packets.
So for security or remote monitoring of machinery where every second counts, that zero latency is everything.
It's non-negotiable. And that low bandwidth requirement is another huge financial win. You're not clogging up your network.
Here's where it gets really interesting.
If we connect this to the bigger picture, HD-TVI was designed to be robust even before you bring fiber into it.
Right, because its performance over old coaxial cable is just phenomenal. HD-TVI can push a 720p signal 500 meters over standard 75 to 5 coax.
500 meters.
When you compare that to the legacy systems people are stuck with, older HD-SDI systems, they topped out at maybe 150 meters.
And even standard analog was only about 300 meters.
So this completely changes the math on whether you can reuse your existing wiring.
It really does. And that robustness is paired with utility. The kit also has an integrated data channel.
What kind of data?
It's a reverse RS-485 channel. That's the standard you need for two-way communication to control a camera.
Ah, so for a PTZ camera, pan, tilt, zoom.
Exactly. You can tell the camera where to look, and that control signal runs right over the same cable. It's all built in.
And with an older HD-SDI setup, how would you do that?
You'd need totally separate equipment just to handle the control data. It's another box, more cost, more complexity.
If we connect this to the bigger picture, what's the takeaway here?
I think it's that HD-TVI systems perfectly bridge that gap between needing high resolution and dealing with the reality of legacy infrastructure.
So what does this all mean for, say, an infrastructure manager?
It means they give you maximum flexibility, especially when you're doing upgrades in phases.
Okay, pulling that thread a bit further, then here's something for you to think about. The DVRs that manage these HD-TVI signals can handle both 720p and 1080p feeds at the same time on the same box.
That's right. They're very flexible.
So, given that you can seamlessly blend resolutions on a single DVR, how does that operational benefit totally change your strategy for a phased rollout compared to systems that force you to have one uniform resolution across everything?
A very good question to consider.
Something to think about next time you're planning an upgrade.